Hello, everybody. Welcome back to Easy Learn. And today's topic is the cosine rule, within which we're going to be doing some practice today. If you haven't watched my cosine rule explanation video yet, pause right here, check the link in the description below, go understand the concept first, and then come back for solving. Today's question is, this is a triangle as you can see with three lengths 8 centimeter, 10 centimeter, and 9 centimeter, and it says find the area of the triangle. Now, this is an interesting question. We are first of all supposed to be looking at what is the formula for area. Now, if we were to be dealing with a right angle triangle, a right angle triangle means that it has 90 degrees. The area formula would be half times base times height. If we were to be dealing with a non-right angle triangle, which means that all the lengths would be different. It would be a non-right angle triangle, different lengths, different angles. Now in that case, if I have a specific base and this height is known to me, in that specific case, I can use the formula base times height, or I just say BH. I could use this formula to find out my area. But if you look at this particular example, I do have a base, but I don't have a height. And it's not that easy or straightforward to find out my height. Therefore, I cannot be using this formula. And I obviously cannot use this one as well. Now there's another formula that I can use when I'm dealing with non-right angle triangles where I don't have a base, I don't have a height, but I do have two lengths and one angle. So in that particular situation, when I have two lengths and one angle, I can be using half AB sine C. Half times A times B times sine C. Now C has to be any angle, and A and B necessarily have to be the lengths that are enclosed between this angle. For example, if I have a triangle like this, and if this is the angle, this is my angle C, or if this is the angle I'm looking at, then for my A and B, I can only take these two lengths that are corresponding with this angle. I can't be taking this side. I can't do that. I always have to take the lengths that are with the C or that are attached with my angle. Now, in this particular question, I have three lengths. Now, it's completely your choice. Which one do you want to use as your angle? You could use this one, you could use this one, you could use this one. If you're using this one, let's say if I call it as number one, if you're using number one, then you would be using the lengths 8 and 10 with that. If you're using number two, you would be using 10 and 9 as your lengths for the A and B. And if you would be using number three, you would need 8 and 9 as your lengths, the A and B. Now the question is, I don't have my angle. So how do I move on with this? How can I do have my A's and my B's, but I do not have my sine C. So for that, first of all, what you gotta do is you have to find any one angle out of this. Now it's completely your choice. Which one do you want? Do you want to take one? Do you want to take two? Do you want to take three? I am personally fond of taking three for some strange reason, so I'm gonna be using this particular angle as the angle that I have to find. So I can rename it as theta, or you could call it as x, y, z, whatever you like. Now, the point is, how do I find out this theta first? So for that, you need to understand that you have three lengths. This is length number one, this is length number two, and that's length number three. So when you have three lengths and one angle, doesn't matter if the angle is missing, but as long as you're dealing with three lengths and one angle, you gotta be using the cosine rule. And the cosine rule says that in order to find the angle, you're supposed to use the formula arrangement cos C equals a squared plus b squared minus c squared over 2 times a times b. Now, which one's my c, the capital C, and which one's my small c? The capital C always has to be the angle that I'm trying to find. That is my theta. And small c always has to be the length that is right opposite to my theta or my capital C. So the length right opposite to my capital C is my small c. So I'm going to be taking these two lengths over there, and I'm just going to be putting all of that up in this formula. So in place of my cos C, I'm just going to take cos theta equals a squared. For my a squared, I'm going to be taking 8 squared plus b squared, that is 9 squared. And it doesn't really matter. I could do 9 squared plus 8 squared instead of 8 squared plus 9 squared. It's all the same thing as long as you know what your a and b are. It's completely fine. You can reverse the order. Now, 8 squared plus 9 squared minus 10 squared. Why did I take 10? Because that is the length right opposite to my capital C. So 8 squared plus 9 squared minus 10 squared divided by 2 times 8 times 9. Now, when you do that on your scientific calculator, first of all, if you want, you can do stuff separately. You can do the numerator first and then keep it, write it down somewhere, and then do the denominator part and then write it down somewhere. Then whatever answers you've got, you divide it. Or if you just want to have a quick calculation, just write everything down in one go on your scientific calculator. That's how I do it. And in your physical scientific calculators, you have an option something like this. There are two boxes and there's a line in the middle which shows the fraction. So in your physical calculators, you can just click that and then have your numerators the way you've written it here, and then your denominators. But because I'm using the scientific calculator on Google, I don't really have that option there. So I'm just putting stuff in brackets. Now these brackets are very, very important when you're using the Google calculator. Otherwise, you're going to end up in a wrong answer. So always your numerator should go inside one bracket, then put the division sign, then your denominator going into another bracket. And then we got to see what answer do we get. So I'm getting something like 0.3125, which means my cos theta equals 0.3125. Now I gotta find my theta. So in order to find my theta, I'm gonna be taking my cos to the other side. And you should be knowing by now that when cos goes to the other side, it turns into cos minus 1. And cos minus 1 is called cos inverse. So therefore, theta is equal to cos inverse of 0.3125. Now again, you gotta check your calculator again. And first of all, make sure your calculator is set on degrees. Secondly, when you will be, since you want the inverse function, you will click this I and V, and as soon as you click I and V, you will have the function cos minus 1 written on top on Google. And if you're using a physical calculator, you can just click shift and press the cos function, so you'll get the cos minus 1. Once you use the inverse function, you'll see on the screen that it says arc cos. So arc cos of 0.3125 gives me 71.79. So now that I have 71.79, that means that my theta is equal to 71.79. Now that I have my angle here, coming back to the original question that says find the area of the triangle, and as already discussed that we're going to be using half AB sine C for that. And since this is the angle, the theta that I found, the lengths corresponding to that are 8 and 9 centimeter. So I'm just going to be writing stuff down. So area equals half times my A, that I could take either as 8 or 9, whatever you wish. And I'm just taking half times 8 times 9, and then I gotta do times the angle, sine of the angle, and I've got my angle or the theta as 71.79. So I'm gonna be writing half times 8 times 9 times sine 71.79. Now again, you check that on your calculator. Let me just remove the stuff there so it's easier for you to figure out. So we have half times 8 times 9 times sine 71.79. That gives me the answer 34.197, which I could just round it off to three significant figures or one decimal place, and I could write 34.2. Now because my lengths were in centimeter, then the area is supposed to be in centimeter square. The unit for area it has to be, if your lengths are given in meters, then it has to be meter square. If it's centimeter, centimeter square. If it's millimeter, millimeter square. But do not forget that areas always have the square attached with them. It's just a rule. So area is equal to 34.2 centimeters square. That's pretty much it. That's how you solve the question. First of all, once you have your specific triangle and you have a few lengths, in order to be able to find the area, you need to figure out that you're going to be using half AB sine C. And in order to have your capital C, you got to find any one of the angle. Now, you could also find the angle for the lengths enclosing 8 and 10. So between 8 and 10, that is the angle one. If you want, just try it out and let me know in the comment section below if you got the same answer for the area when you found through this angle, angle 1, or through this angle, angle 2. Hopefully you're going to be getting the same answer for all the angles you use, because the lengths and angles, obviously whatever you use, it has to be the same. So if you're using angle 1, then the length should be 8 and 10 with that. If you're using angle 2, then the length should be 9 and 10. Okay, so that's pretty much it. If you have any questions, any confusions, let me know in the comment section below. And also, if you want to recheck your answers, just try and find the angles, the other angles, and do the same method and find out the areas and let me know if you got the same answer. And that's pretty much it. Thank you so much for watching Easy Learn. Do not forget to like, share, and subscribe my channel. Take care of yourselves until next time.